Good afternoon, students. Welcome back to chemistry class. Today we are going to study about electronic configuration of atoms. Okay, how can you write the electronic configuration of different elements according to alpha principle? Today we are going to discuss. Okay, electronic configuration of atoms. What do you mean by electronic configuration? The electronic configuration means the distribution of electrons into various orbitals. Okay, the distribution of electrons into various orbitals of an atom is called its electronic configuration. Understood? It can be written by applying the alpha principle, Pauli exclusion principle and Hund's rule. Okay, electronic configuration we can written by applying whatever principles, alpha principle, Pauli exclusion principle and Hund's rule. Okay, what do you mean by alpha principle? Alpha principle already in previous class we studied about that. Alpha principle means in the ground state of the atoms, the orbitals are filled in the order of their increasing energies. Okay, wow. That is the electrons first occupy the lowest energy orbital. Okay, once the lowest energy orbital are completely filled, then the electrons enter into the next higher energy orbital. Okay, according to Pauli's exclusion principle, you know, okay, no two electrons in an atom can have the same set of values of all four quantum numbers. Okay, each and every atom must have unique value for the four quantum numbers. These are about the Pauli exclusion principle. And according to Hund's rule, what about the Hund's rule? Hund's rule means electron pairing takes place until the orbitals contain one electron each. For example, p orbital, we considering the p orbital, px, py, pz, three orbitals there. Once the three orbitals are singly filled, after that pairing there takes place. That about the Hund's rule. Okay, so according to these three principles, we can write the electronic configuration. Okay, the electronic configuration is written as n l power x. N l power x. Here, the n represents, you know, n represents what? It represents the shells or orbits. Okay, shell means it tells us about the energy levels of an atom. Okay, and L represents the subshell. Okay, what are the subshells are having? S, P, D and F. Okay, here X represent the number of electrons in that orbit. Number of electrons present in that orbit. Okay, so n represents number of shell. Whatever the n means, n is equal to k, l and m and n. K means n is equal to 1 means k shell, n is equal to 2 means l shell, first shell, second shell, third shell, fourth shell. Okay, that is n represents. L represents, what do you mean by L? L means SPD. L is equal to 1 means S orbital. L is equal to 0 means S orbital. L is equal to 1 means P orbital. L is equal to 2 means D orbital. L is equal to 3 means F orbital. Okay, these are about the L value. And X represents how many electrons are present in that orbitals. Okay, let us consider the hydrogen atom has only one electron. It occupies the lowest energy orbital. According to alpha principle, how will you write the electronic configuration using this formula? You know hydrogen atom, atomic number 1. So this is the nucleus, first orbit at first shell having the only one electron. Okay, this is the n value is equal to 1 here. So for the n we can write 1. And what is the L value here? When n is equal to 1 means, what is the L value? L value we can write 0 to n minus 1. Okay, so n is to 1 means 1 minus 1 we get 0. Okay, the K shell, the first shell, how many subshells are having? Only one subshell, that is S subshell. Okay, so we know 1 means n, and L means n is to 1 means L value is equal to 0. Okay, 0 means it represents the S orbital, 1s. And how many electrons are present in this subshell? How many electrons? Only one. Okay, only one electron is present in this subshell. So we can write 1s 1. Okay. So the orbital diagram, how will you draw the orbital diagram for this hydrogen atom? Hydrogen atom 1s 1. So we can draw 1s 1, only one electron. This one electron, it is in clockwise direction, up spin. Understood? So the S value here of plus half. Okay, these are about the electronic configuration. Then I am going to write the electronic configuration and orbital diagram for the first elements up to the atomic number 10. Okay, first 10 atoms, I am going to write the electronic configuration and orbital diagram. Already previous classes already I explained this. Once again I will recall now. First upon element, then electronic configuration, and then orbital diagram. First upon element hydrogen, H plus hydrogen. What is the atomic number of hydrogen? You know, all of you, atomic number of hydrogen 1. What is the electronic configuration? 1 S 1. What is the orbital diagram? S orbital, only one electron, only one. S means L value 0 means it represents the S orbital. L value 0 means M value. M is magnetic quantum number value 0. Okay, so only one orientation is there in the S orbital. Only one orientation. How many electrons are there here? Only one electron we can fill in up spin. Okay, and then second atom, helium. Helium, you know, atomic number of helium 2. Okay, atomic number of helium 2. So what is the electronic configuration according to Alpha principle? 1s orbital electron you should fill in the lowest energy orbital. 1s, how much electron? 2 electrons. Okay, so what is the orbital diagram here? S orbital, only one orbital is there. How many electrons? 2 electrons. Okay, so 1s 2. Then third atom, lithium. Lithium, you know, atomic number 3. So how do you write the electronic configuration? 1s 2, 2s 1. 1s 2, 2s 1. You know, this orbital, each orbital we can fill only 2 electrons. Only we can fill the each orbitals. Okay, so this orbital maximum 2 electrons only we can fill. So one electron is up spin and another one electron is down spin. Okay, one is clockwise direction and another one is anti-clockwise direction. This is 1s 1 orbital, and then 1s 2 orbital, and then 2s 1. This is the 2s orbital. How much electrons there? Only one electron. So we can write in up spin. Okay, after that beryllium. What is the atomic number of beryllium? Atomic number 4. So what is the electronic configuration? 1s 2, 2s 2. 1s 2, 2s 2. Okay, so orbital diagram, how will you draw the orbital diagram? First 1s 2 orbital. 1s orbital, how much electron? 2 electron. One is up spin and another one is a down spin. After that, we can draw the 2s orbital. 2s orbital, first up spin and down spin. 2 electrons are there. Okay. After that, boron. What is the atomic number of boron? 5. So electronic configuration according to Alpha principle, how will you write? First 1s orbital, second 2s orbital. So totally 5 electrons there. After that, we can write the 2p orbital. Okay. So 1s2, 2s2, remaining 1 electron we can occupy in p orbital. Okay. So what is the orbital diagram? First 1s orbital, how many electrons? 2 electrons. Then 2s orbital, how much electrons? 2 electrons. Then 1 electron remaining we can accommodated in p orbital. P orbital, how many orbitals there in p subshell? There are 3 orbitals are there in p subshell. Okay. So what is the name? How will you give the name here? 2px, 2py and 2pz. Okay. Here only 1 electron is there. So 2px1. Okay. 2px1. Only 1 electron we can occupy in the p orbital. After that, carbon. Carbon atomic number 6. Electronic configuration, first 1s2, 2s2. After that 2p, remaining 2 plus 2, 4, remaining 2 electrons there. 2 electron we can accommodated in p orbital. How will you draw the orbital diagram? First 1s2 orbital, how much electron we can accommodate? 2 electrons. After that 2s2 orbital, 2s orbital, how much electron? 2 electrons. And then 2p orbital. 2p orbital, p subshell, how many orbitals there? 3 orbitals there. 2px, 2py and 2pz. Here how much electrons there? 2 electrons. So first electron. According to Hund's rule, how will you fill the electrons in their degenerate orbital? Degenerate orbital means the for example p orbital, d orbital, f orbital. Degenerate means every orbitals in the same subshells have the same energy. Okay, that is the degenerate orbital. According to Hund's rule, how will you fill the electrons in the subshell? The electron pairing does not take place until the available orbitals contain 1 electron each. Okay, here 3 orbitals are available here. How can you fill? All the 3 orbitals, first upon we should fill singly. Okay, we should fill singly. After that we can pairing. We can pairing the electrons. Okay, so here 2 electrons for carbon atom, p orbital, 2 electrons there. So first upon we should fill singly. Okay, first one and then next one. Okay. And nitrogen atom, nitrogen atomic number 7. Atomic number 7. So electronic configuration 1s2, 2s2, remaining 3 electrons. 3 electron we can accommodated in p orbital. Okay. So how will you draw the orbital diagram? First 1s2 orbital, 2 electrons, and 2s orbital, 2 electrons. After that 2p orbital, 2px, 2py, 2pz. How will you fill the electrons in the p orbital? First upon we should fill in singly. Okay. Okay. This is a half-filled orbital. Half-filled orbital. Okay. Half-filled orbital means all the p orbitals are having the 1 electron. Half-filled. Understood? And then next, oxygen atomic number 8. Electronic configuration 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. How will you draw the orbital diagram? First 1s orbital, 2 electrons, and 2s orbital, 2 electrons, and 2p orbital. How much orbitals there? 3 orbitals. 2px, 2py, 2p z. Okay, how many electrons are there in p orbital? Totally 4 electrons. How will you fill the 4 electrons? According to Hund's rule, first upon we should fill the 3 orbitals, each orbitals electrons singly occupied first. After that, remaining 1 electron we can accommodate it in px subshell, px orbital. Understood? And then fluorine atomic number 9. What is the electronic configuration? 1s2, 2s2, 2p5. What is the orbital diagram? First 1s orbital, 2 electrons. Next 2s orbital, 2 electrons. And 2p orbital, totally how much electron? 5 electrons we can accommodate it in 2p orbital. 2px, 2py and 2pz. Okay. The 5 electrons, how will you fill? First singly, you should fill the singly, and then after remaining 2 electrons, we can fill the 2px and 2py. Understood? Then neon. Neon, what is the atomic number neon? 10, atomic number 10. So electronic configuration 1s2, 2s2, 2p6. Okay, 1s orbital, how much electrons we can accommodate? 2 electrons. 2s orbital, 2 electrons. Then 2p orbital, how much electron we can accommodate it? 6 electron. Okay, 2px, 2py and 2pz. First upon we should fill singly according to Hund's rule. Okay, totally 6 electron, so it is completely filled. Okay, 3, and after that down spin 3 electrons. Okay, so this for the neon, it is already you know this is the stable electronic configuration, that is completely filled electronic configuration. Okay, completely filled. For nitrogen it is the half filled, and neon is the completely filled electronic configuration. Okay, understood? These are all about the electronic configuration of first 10 atoms according to alpha principle. Okay. Here we are going to study about some elements. Some elements differ from expected electronic configuration in accordance with the alpha principle. Okay, you know how to write the electronic configuration according to alpha principle, you know about that. Okay, but some elements such as copper, chromium, silver, gold, palladium, etc., some elements differ from the electronic configuration according to alpha principle. Okay, the electronic configuration of these elements differ in accordance with the alpha principle. How it will differ? Let's see. First upon chromium, atomic number 24, you know how to write the electronic configuration. First upon 1s2, after that 2s2, after that 2p6, totally 24 electrons we need, 10 electrons, after remaining 14 electrons are there. After 2p6 we can write 3s2 and 3p6, after that 4s2. After 4s2 we can write the 3d orbitals. 3d, maximum number of we can fill d orbital, we can fill maximum 10 electrons. Okay, here 2 plus 2 4, 4 plus 6 10, 10 plus 2 12, 12 plus 6 18, 18 plus 2 20. Okay, remaining 4 electrons we need. These 4 electrons we can fill in d orbital, 3d4. Okay, this is the expected configuration according to alpha principle, but it is not stable now. Okay, how it is not stable, I will explain now. So first upon we can draw the orbital diagram. 1s orbital, 2 electrons, 2s orbital, 2 electrons, 2 p orbitals, 6 electron. According to Hund's rule, we can fill the electrons in the orbital. First upon singly fill the electrons. Okay, 1, 2, 3. After that, 4th electron onwards, we can pair up the electrons to p6. After that, 3s2. Then 3p6, 3p orbital, 3px, 3py, 3pz. According to Hund's rule, we can fill the electrons. First upon singly fill. After remaining for the p orbital, from the 4th electron onwards, we can pair up the electrons. Okay, 3p6. After that, 4s2. This is the 4s2 orbital. And then after that, 3d orbital. D orbital, how much orbitals are there in d subshell? Totally 5 orbitals there. Okay, the total number of electrons maximum we can accommodate 10 electrons we can accommodate in the d orbital. Okay, so totally 5 orbitals are there in d subshell. We can designate it as 3dxy, 3dxz, 3dyz, 3dx square minus y square, 3dz square. Okay, how much electrons are having here? Total 4 electrons. Okay, first according to Hund's rule, we can fill singly. Okay, first, second, third and fourth. Okay, totally 4 electrons only having here. But it is not stable. Why it is not stable? It is explained by one of the rule, that is rule of half-filled or completely filled orbitals. Rule of half-filled or completely filled orbitals. What said this rule? That is, the orbitals tend to become half-filled or completely filled since such orbitals are more stable than other orbital. Okay, the orbital tends to become half-filled. Half-filled means, what do you mean by half-filled? This is not half-filled or this is not completely filled. Okay, because half-filled means d subshell. Totally 5 orbitals are there. These 5 orbitals, to become half-filled, it need 5 electrons. Okay, to become half-filled, it need 5 electrons. Okay, then only it can stable. Okay, it is not now, it is not stable. So for the s orbital, this 4s orbital, the electrons, 1 electron, the d orbital need 1 electron to get the half-filled configuration. Okay, so the 4s orbital, the 1 electron give to the d orbital. Okay, so how will you write the electronic configuration now? Chromium 24, 1s2, 2s2, 2p6, 3s2, 3p6 and then 4s2. Okay, this is the expected configuration, but here for the more stability, this 1 electron from the s orbital, 4s orbital, it is shifted to the d orbital. Okay, so the 4s orbital to become 1 electron. And then this 1 electron, it go to the d orbital. So d orbital, it get 3d5 and get the stable configuration. Okay, how will you write the orbital diagram? 1s orbital, 2s orbital, 2 electron, 2p orbital, 6 electrons, 3s orbital, 2 electrons, 3p orbitals. How much electrons? 6 electrons. Then 4s orbital, how much electron now? Only 1 electron. This 1 electron, it is shifted to the d orbital. Okay, to make the stability. So d orbital, now we get 5 electrons. Okay, 3dx, 3dxy, 3dxz, 3dyz, 3d x square minus y square, 3d z square. Okay, totally 5 electrons now we got. Okay, so it is now stable. This is we called as half-filled configuration. Stable half-filled configuration. Okay, this is the actual configuration for chromium atom. Okay, another one example, copper. Copper also, it is not according to the alpha principle. The electronic configuration, it is not obey the alpha principle because it is according to alpha principle. If we write the electronic configuration, it is not stable. Okay, so the electron from the s orbital, one electron goes to the d subshell. After that, it will stable. So expected configuration, the copper atomic number 29, the expected configuration. How will you write the expected configuration? First, 1s2, 2s2, 2p6, after that 3s2, after that 3p6, and then 4s2, and then 3d. How much? 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20, and then 20, 9 electron we need. So 3d9. Okay, this is the expected configuration according to alpha principle. Okay, this is the expected configuration. What is the alpha principle? According to alpha principle, what do you mean by alpha principle? Once the lower energy orbital is completely filled, then the electrons go to the next higher energy orbitals. Okay, ground state of the atoms, the orbitals are filled in the order of their increasing energies. Increasing energies only the electrons are filled. Okay, but here according to alpha principle, when we are writing the electronic configuration, this is now not stable. Okay, it is explained by the half-filled rule of half-filled or completely filled. Okay, rule of half-filled or completely filled. What's said? It is said to be the orbitals tend to become half-filled or completely filled since such orbitals are more stable than other orbital. Now, I written this, the chromium, the actual configuration is more stable than expected configuration. Expected configuration I written according to the alpha principle. It is not stable, but the actual configuration stable. Okay, this is the stable configuration. Then copper also here 4s2 3d9. When we are writing the orbital diagram, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d and 9. D subshell totally 9 electrons are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it is stable or not? This is not stable now because it is not half-filled configuration and not in completely filled configuration. Okay, so the one electron from the s orbital, it is shifted to the d orbital. Okay, then it will get the stable configuration. This is the expected configuration according to alpha principle. Okay, but actual configuration, how will you write? 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 4s2. The one electron from the s orbital go to the d orbital. So we can write 4s1, then 3d10. Okay, how to write the orbital diagram? 1s2, 2s2, 2p, 6, 3s2, 3p6, then for a orbital, how much electron now? Only one electron. One electron goes to the d subshell for the stable, to forget the stable configuration. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. One electron came to the d subshell from the s orbital. Understand? Now it is stable. How it is stable? It get the completely filled configuration. Completely filled configuration. Okay, according to rule of filled or completely filled. Now this chromium and the copper atoms are stable. Okay, so okay, understand. Due to the stability, one of the electron from the 4s orbital in chromium and copper to attain the half filled and the completely filled configuration respectively. Okay, understood? So okay, so for the p orbital filled configuration, 3 electrons in the p orbital, it will be stable. Okay, and 6 electron in this p orbital, it will get the completely filled stable configuration. For d orbital, the 5 electron, okay, suppose to get the 5 electron, it is stable half filled configuration. Okay, maybe it get the 10 electron for the d orbital, it will completely stable. Okay, completely filled configuration, stable configuration. For the f orbital, how much electron need for the half filled configuration? Totally 7 electron need to get the half filled configuration, because f orbital totally how much orbitals are there? Totally f subshell, totally 7 orbitals are there. Okay, so 7 electron need to get the half filled stable configuration. Okay, how much electron need to get the completely filled configuration? 14 electron. F subshell need 14 electron to get the stable completely filled configuration. Okay, understood? These are the about stability of the electrons. Okay, understood? Okay, students, today your assignment, what is electronic configuration? Question number 1, what is electronic configuration of an atom? Second question, write the electronic configuration and orbital diagrams for the first 10 elements. Write the electronic configuration and orbital diagrams for the first 10 elements. Okay, students, you should study every day, portions every day you should study and write and send me through my WhatsApp number. Don't forget. Okay, thank you all of you.